Hello, algebra students. Mr. Lawrence here, and this is your third, and it will probably be your final review video. I don't think I'm going to post one Wednesday night because you really should be prepared. So this one's going to have a hodgepodge of a few things. The only thing it's not going to have is the graphing linear equations, finding slope. You can go back and watch those videos if you need to. All right, so let's talk about rational and irrational numbers. Remember, a rational number either terminates or repeats. It includes all fractions. All fractions are included here. Did you hear that, Chris? All fractions. Fractions, where are you? Oh, I know what I'm doing. Silly me. I'm looking for a fraction. The word fraction, I think I saw it somewhere around here, includes all fractions. Okay? Fractions. So, where would these numbers fall? Well, pi is a number that goes on forever without repeating. So it doesn't terminate, it doesn't repeat, it's irrational. 3.14 is not equal to pi. It's a terminating decimal. How do I know it's terminating? It ends. It stops at the 4. 6.3, that little bar above it, that means it's repeating. It's a rational repeating number. 5.23 dot dot dot, that is irrational, going on forever without repeating. Fraction. The fraction is going to be rational, but you may not know if it's terminating or repeating. We'll check that in a second. The square root of 9 is 3. Well, that's terminating, isn't it? 3 doesn't go on forever. Or if you, yeah, it doesn't go on forever, it stops. Okay, 1/3, another fraction. We'll check that in a second. Now, the square root of 24. Well, you don't know a number times itself that equals 24. Neither do I. That is an irrational number. Okay, if it's not a perfect square, it's irrational. Hold on 1 second for me. Okay, I brought up my graphing calculator. I want to do 1/5. Well, I'll do 1 divided by 5. Okay, as a decimal, it's the same as 2/10 right there. Well, that means it's a terminating fraction, right? As a decimal, it's 0.2 or 2/10. Now, let's check 1/3. Some of you already know 1/3, but if you don't, check it on your calculator. Do your best on the test. You guys deserve it. You deserve it. All right, looks like it's a 0.3 repeating, doesn't it? So that would be a repeating rational number. There you go. Okay, very good. Let's move on to something else now. Order of operations. Remember, we're going to do our parentheses first. Then we'll do our exponents. And then we'll take care of multiplication and division, going from left to right. Then we'll take care of addition and subtraction, going from left to right. So on this problem here, the first step, there's nothing to do inside the parentheses. I don't see any exponents, so I'm going to do this multiplication here. So I'm going to get 3 minus 2 times 5 is 10 plus 6. Now, going from left to right, I can say that this is -7 plus 6 is -1, and there is my answer, -1. All right, moving on to problem number 2. 3 minus 5 is -2. But I have -2 squared. So I'm going to have 5 minus 4. And what is -2 times -2? Why, it's +4 minus 6. All right, now inside I'm going to do this, the multiplication. I'm going to have 5 minus 4 times 4 is 16. These brackets count as parentheses. This will be -11 minus 6 will be -17. Now, by the way, your calculators do the order of operations, and calculators are fair game on the test. So please use them. All right, scientific notation. Some of you tried to ask about it, and I wasn't ready to answer your questions. Multiplication. Scientific notation by multiplication. By the way, you can do this on your calculator. First, we're going to multiply the coefficients. 5.3 times 4.1. And when we do so, we're going to get a 3. That's going to be 5 and 12 is 7. We're going to carry the 1, 21. And it looks like 1, 2. So we're going to get 21 and 73 1/100ths. Okay, now we have to multiply the tens together. Well, when bases are the same, we add the exponents in multiplication. So I'm going to get 10 to the 12. Now there's a problem with my answer. Remember, for scientific notation, my number always has to be between 1 and 10. single digit number. So I'm going to move this decimal point by dividing by 10 here. It'll cause the decimal point to move, but if I divide by 10 on the coefficient, I have to multiply by 10 on the base. So I'm going to get 2 and 173 1,000ths times 10 to the third. If you heard the bell, I have to pause now. Julia Gross just walked into the room, and I've got some students coming, so I'll be back with you shortly. Okay, it's been several hours, but I'm going to pick up where I left off. So I'm going to do some division by scientific notation. And let me see here. First, I'm going to divide 1.44 by 1.2, 1 and 44 hundredths by 1 and 2 tenths. Now, you are allowed to use a graphing or excuse me, a calculator, but you don't always need to. If I could do, say, 1.44 divided by 1.2 and multiply this number by 10 and multiply that number by 10. My decimal point moves there. 12 will go into 14 one time, and then I'll subtract, and I'll get 24, and 12 will go into 24 two times. And so when I divide, I get 1 and 2 tenths. Now I divide here. 10 to the 8th divided by 10 to the 2nd is 10 to the 6th. And there you go. I don't have to convert this one to scientific notation because it's already there. All right. Now, adding and subtracting scientific notation. Second period got to see this in class because they had me for the extra hour. I talked a little bit about it to 8th period, but not as much. I can't add these together right now because the bases don't have the same exponent. I want this one to turn into a 4. So I'm going to multiply by 10 to the first. But I've just changed the number. So I'm going to divide the coefficient, or the decimal, by 10 to the first, which causes the decimal point to move there. Now I have 6 and 12 100ths plus 33 100ths, and it's times 10 to the fourth and times 10 to the fourth. And so I will get 6 and 45 100ths times 10 to the fourth. It's already in scientific notation because the coefficient is between 1 and 10. All right, now this one is the same thing. I can't subtract right now, so I'm going to multiply by 10 to the first, and I'm running out of room. Oh dear. Oh, woe is me. Let's move this stuff over. Yikes. Okay, so I'm going to multiply by 10 to the first. And again, over here, I'm going to divide by 10 to the first, which causes the decimal point to move. So now I have 8, 12 minus 2, 8, 4. Okay, now I know they're both 10 to the fifth because of the manipulation I did. Now remember, we can't just go 4 minus 0. We don't read up, we read down. So I can't take 4 away from 0, so I'm going to do some borrowing. I'm going to borrow 10 from here, turning that into 10. That'll turn that into a 1. I had 2 10s. Now I have 1 10 here and another 10 here. 10 minus 4 is 6. I can't take 8 away from 1. So I'm going to borrow from the hundredths. I'm going to take 10 tens and put them here. So now I had 11 tens. I had 1 10, now I have 11. 11 minus 8 is 3. Okay, and technically it'd be tenths, but the principle holds. All right, here I've got holes. So I'm going to take one of the holes away and put it here. So now I have 10 tenths. Well, 10 tenths minus 2 tenths is 8 tenths. And my subtraction is that. So that'll be times 10 to the fifth. And there we go. All right, moving right along. Exponents. Remember that when we multiply the coefficients first. 7 times 3, 21. Now I multiply x to the 6th times x to the 5th, and I get x to the 11th. I do y times y, and I get y squared. There we go. When I have 45 x to the 10th, y cubed z to the 5th, divided by 45x to the 6th, y to the 8th, z to the 5th. I would much rather think about this as a fraction problem. That's not a decimal there. That's just a stray mark. Let me move that out of the way. All right, I'm going to do 45x to the 10th, y cubed, z to the 5th in my numerator. That'll be over 5x to the 6th, y to the 8th, z to the 5th. Now, if I do 45 over 5, that'll be 9, right? X to the 10th over x to the 6th, that'll simplify to x to the 4th in the numerator. Y cubed over y to the 8th, that'll be a y to the 5th in the denominator. And the z's cancel out. And there's my simplified answer. Remember, x to the 10th over x to the 6th means this. And x to the 6th, I'm going to cancel, 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 cancel. And look, there's 4x's being multiplied, or an x to the 4th right there. Right? Okay, the same with the y's. I'm not going to write them all out, but I'll have 3 y's in the numerator, 8 y's in the denominator. I'll have 5 y's in the denominator. Now, this is a problem over here, 5 to the 0 power. Please, 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 if you're on the test, don't assume you know. Type it in the calculator. You will get 1 for an answer. I've taught you why, but check yourself on the calculator. All right, this one here. Sam Wilson was asking about this in the end of class. Don't worry, Sam, we're going to do some in class, but hopefully in the video you'll see how to do this. First thing I'm going to do, I'm going to simplify everything inside. So I've got 3 over 27. Well, that's going to give me a 9 in my denominator. I've got a negative 2 for an exponent. He's going to shoot upstairs. I'm going to have x to the 6th times x to the 2nd, which is x to the 8th. Y to the 9th over y to the 12th is going to give me a y cubed in my denominator. That's raised to the negative 2nd. The negative exponent means to use the reciprocal. So I'm going to have 9y cubed over x to the 8th. Now it's ready to be squared. I'm not sure who it was. I can't remember if it was Holly or Kayla, somebody, maybe even Samira, somebody when they're at this point goes like this to make sure they don't make any silly mistakes. There's absolutely nothing wrong with that. The only problem is if this power is like a 17, then you got to write 17 of those out. But it's not a 17, so there's no problem. 9 times 9 is 81. Y cubed times y cubed is y to the 6th. And x to the 8th times x to the 8th is x to the 16th. Now I could have gotten that answer by squaring 9, multiplying my power to a power to get y to the 6th, and then multiplying the 8 times the 2 to get x to the 16th. Either way, the important thing is get the right answer. Okay, I think that's it. I mean, I'm not going to go too heavy into slope-intercept form, y equals mx plus b, right? If you're given 2 points like 5, 7, and let me think here. Let's go with, say, 6, 10. To write the equation of the line that passes through those two, well, I'll do 10 minus 7. And I'll do 6 minus 5. And so I'll get a slope of 3. Then I take y equals mx plus b. I fill in a y, 10. I fill in the slope, which is 3. I fill in an x coordinate, which has to be 6. Why does it have to be 6? Because I chose 10 for my y. Had I put 7 for my y, then I'd have to use 5 for my x. And then I add b. So I get 10 equals 18 plus b. I'll subtract 18 from both sides, and I'll get negative 8 equals b. Now that I know m and b, I can write my equation. Y equals 3x minus 8. And there you go. Now, I strongly recommend that you go back and you watch some of the slope-intercept videos, maybe the test review video that we just had. All right, that'll be it for today's lesson. Mr. Lawrence signing off. Have a good night, everybody.